What's good, math family? In today's review, we're going to break down the key methods to use when solving polynomial equations. Let's get started. So when we're dealing with polynomial equations, we're going to focus on solving by factoring. So one of the first key methods that we can use is the GCF. So in problem number one, we pull the GCF out of x. Then we're left with x squared is equal to 0. And now we're focusing on what's inside of the parentheses so that we could solve. And we should notice that this is a perfect square trinomial, so the factors are going to be the same. So GCF of x stays on the outside. We break the trinomial down as x minus 3 times x minus 3. And this is equal to 0. Now we set all our factors equal to 0, so x is equal to 0 is our first one. And then we notice that these two are the same, so once we solve, we're going to get the second factor of x is equal to positive 3. Now, in example number 2, we're going to use a much different method, and this method is going to be group factoring. So we're going to group the first two terms and the last two terms. And what we want to do is basically use GCF factoring to break down this polynomial to its lowest term. So let's go on. So if we look at this, we could only take out an x squared term. Once we take out x squared, we're left with x plus 3 on the inside. Now, in the second set of parentheses, 4 and 12, we could take out a 4. Once we take out 4, what's left inside the parentheses is also going to be x plus 3 is equal to 0. So these common factors, which you'll also hear teachers say common ratios, right? They're the same. We now know that this is correct because of the same thing inside the parentheses. So our first factor is x plus 3. And then the second factor is always what's outside of the parentheses. So that is the x squared minus 4. And we set both of these equal to 0. So once we continue solving, our first factor is equal to negative 3. And then the second one, remember that this is the difference of squares. So this breaks down as x plus 2 is equal to 0. So we get x is equal to negative 2. And our second factor of x minus 2 is equal to 0. So we're going to get x is equal to positive 2. In problem number 3, we can use a different method, which is basically the AC method of factoring. So once we multiply the coefficient for a and the constant, we get 36. And we know that whatever these factors add to, it's going to give us a negative 13, the b term. So once we break this down, we're going to break this down as negative 9 and negative 4. That's how we get the positive 36 when we multiply, negative 13 when we add. So once we break this down, we have x to the fourth minus, and then now we substitute our factors in. 9x squared minus 4x squared plus 36 is equal to 0. And at this step, family, this is when we now go back to our group factoring. So I pull out a greatest common factor of x squared. We're left with x squared minus 9. And then in the second set of parentheses, when we pull out a 4, I'm going to be left with x squared minus 9 again. So now once we look at this, family, we're noticing that there's a lot going on. So number one, here goes our first difference of squares. So once we break this down, we have x squared minus 9 is equal to 0. This is going to break down as x plus 3 times x minus 3. So we know that our x factors are going to be negative 3 and positive 3. But we can't forget that we have to go back now and combine what's on the outside of the parentheses. So once we do that, we have x squared minus 4 is also equal to 0. And then once we break this down, we're going to get x plus 2 is equal to 0 and x minus 2 is equal to 0. So our answer or other answers will be x is equal to 2 and x is equal to negative 2. Another way that you'll see this expressed is as a solution set where they'll put something like this. X is equal to, and in braces, they're going to list all of our factors. So negative 3, negative 2, positive 2, and then positive 3. So this is another way just to express the same answer. In the next set of examples, we're now dealing with polynomial equations that are not set equal to 0. And solving these are going to be a little bit different compared to the first section. So in our first example in red, we're going to have to subtract 10b. So we have 5b squared minus 10b is equal to 0. Now that it's set equal to 0, we could solve. And the best method is to pull out the greatest common factor of 5b. We're left with b minus 2 is equal to 0. So we set the factors equal to 0. First one is b is equal to 0 after we divide by 5. And then b minus 2, once we solve, we're going to get b is equal to positive 2. Now, when we go over to our next example, x squared minus 9 is equal to 0. Although the equation is set equal to 0, we're going to solve this one a little different. We want to isolate the x. So we're going to move our constant to the other side. So we have x squared is equal to positive 9. And now at this step, this is very similar to completing the square. So we're trying to get rid of the exponent. And to do that, we have to take its root. So square root and exponent cancel out. We're left with x. And this is equal to positive or negative the square root of 9. Because if we square a negative number, we'll get a positive one. So the answer is going to be plus or minus 3. Now, just remember with these polynomial equations, we do have extraneous solutions, which we've linked videos down below if you need help. But in this type of problem, let's say we substituted negative 3 in. So we have negative 3, which represents x, squared minus 9 is equal to 0. Once we simplify, we are going to get a true statement because 0 is equal to 0. This is just how you properly check to determine if your solution is extraneous or not. Now, in our third example in green, we have to be mindful, right, that polynomial equation is not set equal to 0. So once we subtract 30x, we have 3x to the third minus 9x squared. Now that we've set it equal to 0, we are now able to factor, and the best first step is GCF. So we take out a GCF of 3x, we're left with x squared minus 3x minus 10 is equal to 0. And when we pay attention to what's inside the parentheses, right, 3x stays the same, but what's inside the parentheses is now going to change to x minus 5 times x plus 2. So now when we get to this last step of setting the factors equal to 0, this is what we should have. So x is equal to 0 is my first answer. Our second answer is going to be x is equal to positive 5. And in the third answer, x plus 2 is equal to 0. We're going to get x is equal to negative 2. And now we've solved that polynomial equation. Now, when we go over to our last example, I'm going to show you a different method that I did not touch on in this video. So we know the very first step is to rearrange the quadratic equation. So once I add 2 and put it in standard form, we have 3x squared plus 7x plus 2 is equal to 0. So right here, guys, I'm going to go back to the AC method, but I'm you really use the slip and slide method. So once we multiply these two, right, A and C, we get x squared plus 7x plus 6. And matter of fact, let's just erase this because we don't need that. So now when we look at this family, we're trying to find the factors that when we multiply, they're going to give us 6. When we add, they're going to give us a 1. So this is pretty simple. This is going to turn into x plus 6 times x plus 1. But now the key thing here, and where a lot of students get the slip and slide factoring incorrect, is that they forget this part. We have to now divide by the same factor we multiplied by. So now when I come in here, we're going to divide by 3 because we multiplied by 3. So as we slide out some more, this is going to turn into x plus 2 because we divided and got 2 is equal to 0. So x is equal to negative 2. And when you have something like this where the numerator cannot be divided by the denominator and get a whole number, you're going to take this denominator and just put it in front of the x variable. So this turns into 3x plus 1 is equal to 0. Right, we're going to isolate the constant. So we have 3x is equal to negative 1. And when we divide, we know x is equal to negative 1 over 3. So when we're talking about solving polynomial equations by factoring math family, these are key methods that you can use to successfully do so. We're going to follow this video up with synthetic and long division of polynomials. Please be on the lookout for that. And don't forget to smash the like button for us, subscribe to the channel, and leave comments down below if you had questions on this video or if there's topics you guys would like to see on our channel in the future. Thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.